Hi guys, this is Mrs. Zero coming at you from Einstein High School. Today we're going to be working on Unit 2, Topic 1, Question 21 from the Algebra 1A exam review packet. You are playing a carnival game. You now have 50 prize tokens. Each time you win a game, you will get 8 prize tokens. As soon as you get at least 100 prize tokens, you will stop playing. I have lots of important information here. We currently have 50 prize tokens. That's where we're starting. Um, each time you win, you get prize tokens, and as soon as you get at least prize tokens, you will stop. So they're kind of restricting how many tokens we can earn there. All right, the function t of w equals 50 plus 8w represents the total number of prize tokens that you have after winning w game. So we have an equation and function notation there. So there's that t of w. We have 50, which was how many we had, our starting point there. And that 8W represents 8 tokens per win. Okay. Part A. Fill in the missing values in the chart below. Okay. So at 0 wins, well, we already had 50 tokens. That was our starting point. After 2 wins, well, 2 wins is going to be 16 tokens. Let's make another little table here. So we have W, T of W. So we have 0, 50. After 1 win, then we're going to have 58 tokens. So after 2 wins, we're going to have another 8, which is going to be 66 tokens. After 3 wins, we're going to have another 8, which is going to give us 74 tokens, and after 4 wins, we'll have 82 tokens. I just wanted us to see that this table is increasing. This is going to be plus 2 here, so that's not going to be plus 8, it's going to be plus 16. So be very careful, make sure you check before you just start adding something. The 2 is going to be 66, and we figured out that 4 is 82. Okay. What are the independent and dependent variables? So again, the question is, who's in control here? If you look at our function, we have t of w equals 50 plus 8w. Well, our input variable, or our independent variable, is going to be the number of wins. Because that's what's going to determine the number of tokens. And so the number of tokens is going to be our dependent variable. Okay, and so I'm going to write that out. The number of tokens depends on the number of wins. I think that makes sense. All right, scrolling down to part C. Change my color here. Black is a little boring. Spice it up. All right, part C, relate the variables using the expression is a function of. If you remember from question 20, we can actually replace that depends on with is a function on. So if the number of tokens depends on the number of wins, then the number of tokens is a function of the number of wins. And if you think about our equation, that really makes sense here. We had t of w equals 50 plus 8w, and we have to input a win value here in order to get the number of tokens. So that's why that's our independent variable. Okay, part D. Are the variables discrete or continuous? Why? Okay. This can be tough to figure out, but what we really want to think about here is there a limit involved with the number of tokens we can have? And what I mean by that is, can you have a half of a token? No. Can you have a quarter of a token or an eighth of a token? No, you can't. Our tokens are very specific. There's 8 tokens for each win. So that's actually going to be representative of a discrete function. And there's a lot of ways that you can explain the reason, but what I'm going to say is you cannot have part of a win or part of a token. Okay, so the values we have are very specific. 1 win is going to give us 8 tokens. 2 wins is going to give us 16 tokens, and so on. Continuous functions are going to have everything in between 50 tokens and 82 tokens. Every little decimal in between would be represented, and that's not the case we have here because we cannot have a part of a token. All right, part E. What does the statement T of 3 equals 74 represent in this situation? Okay, I am going to write out that that means T of 3 equals 74 is how we read that. But in the context of this situation, we want to be specific. So what we know here is that when W, remember our function notation was T of W, okay? So instead of W there, we have T of 3, so we know that W equals 3. Therefore, the number of tokens is 74. So to put that into words, we're going to say after 3 wins, person here, you will have 74 tokens. Okay. Complete the domain. Okay, all right. The domain value is going to be the number of wins. It's our independent value. And remember, going back up to our question, as soon as you get at least 100 prize tokens, you will stop. So let's see how many wins it takes to get there. I'm going to finish my table here. I'm going to keep going. So after 5 wins, I'd have 90 tokens. After 6 wins, I'd have 98 tokens. I'm not to 100 quite yet. And after 7 wins, I'm going to have 106 tokens. And so as soon as you get at least 100 tokens, we did that, we're going to stop. So now that we have our completed table, we have our domain, the W, and our range, the number of tokens. So we're going to use that table to complete. So we started at 0 and we ended at 7. So it's going to be 1, 2, 3, 4, 5, 6, 7. Okay, is that it? Nope. Okay. Part G, what number would replace the variable W in the statement T of W equals 90? I'm going to write that out so we know that T of W equals 90. That's what that says. And so think about what information we have here. What value of W? So W is unknown, but the number of tokens is known. We know that we have 90 tokens. And so using our table that we made, when did we get 90 tokens? How many wins did it take? And that's going to be after 5 wins, we'll have 90 tokens. We can also use the formula. Remember we had a rule, T of W, or a function here, was equal to 50 plus 8W. Well, if we know that T of W equals 90, we can replace that value here and solve. I'm going to subtract 50 from both sides. Give myself some more room. And that's going to give me 40 is equal to 8W. And when I divide both sides here by 8, I get that W is equal to 5. two different ways to solve the same problem. You can use a table, you can use the function, and we got to the same place. W is equal 5. Okay, and that is going to wrap up question 21.